Hey guys, we're looking at recapping, getting ready for our CAASPP state testing for 11th grade. This video is looking at inequalities, solving them, graphing them, linear equations with inequalities also. I think it was a system of inequalities too. All right, so we've got two questions we're gonna look at. This is the first one. Again, the question numbers are kind of weird. I pulled them from the sample practice test that's on the CAASPP website. So these questions are public. If you would like to practice these on your own, again, you're going to search CAASPP math practice test. You'll click on that first link. You'll use the guest login to jump in and make that take that practice test. So these are questions from the practice test. Okay. So it says, which inequality represents all possible solutions of -6n, and then that symbol is less than, because it looks like an L with really bad posture, less than -12. So it looks like our goal here is going to be to solve for n. We want to get n by itself. And we're noticing, right, there's this coefficient here, this -6. We do not want it here. We want to move it to the other side. The only way we can move something over is by using the inverse operation. So instead of multiplying, we're going to go ahead and divide both sides by -6. Something interesting that happens when we are dividing by a negative number is that it will flip the sign. So in our class, right, we've done the wee-oo, we've done the done those like fancy noises to just remind us that something's happening, that we're going to be changing the sign. So we're going to go ahead and flip it. It was a less than symbol, and now it's going to become a greater than symbol. The n is now isolated, and if you need a calculator, right, you can use that. -12 divided by -6 is going to be +2, right, because the signs change. But the big idea here is that the inequality is going to flip. So anytime we are multiplying or dividing by a negative number, that's the big idea with inequalities, is that the sign is going to flip. So again, anytime we multiply or divide by a negative number, the inequality is going to flip. So it was once a less than, now it is a greater than symbol, greater than. All right, and we can check, here it is, n is greater than 2, and we can box our answer. So this one was a tricky one because we had to flip the sign, flip the inequality. So be on the lookout for that. Again, if we're subtracting, we will not be flipping the sign. It's only if we are multiplying or dividing. I'm going to write that out too, because it's important. So only flip the inequality when we multiply or divide both sides by a negative number. Inequality. There we go. All right. So that's our first one, looking at inequalities. Again, this is kind of just a quick refresher of what, helping you guys prepare for your CAASPP state testing, and also just like a quick refresher of some concepts we've already covered. All right, this is now graphing with inequality, and the question is to click on the region. So once you, in the testing, you'll click and it will like show you the shaded region. So you'll highlight, click on one of the regions, and it will automatically shade it for you. So we want to find the solution for this system. All right, but notice that it is solution for an inequality. So we'll kind of refresh here when we're graphing. So it looks like they already have it graphed for us, which is very nice. So it's in slope-intercept form, right? It's in y equals mx plus b. Okay. Let's label them. That might be helpful. So this one, the y-intercept is at +3. So this is going to be, I'm going to label this. This is equation 1. This is equation 1. Y-intercept is at -2, so this is going to be equation 2 over here. That's going to be helpful in a moment just to identify, okay, what are they giving us? So they've graphed first line, they've graphed second line, and now we're asked to shade. So refresher for inequalities when we're looking at linear inequalities, so graphing a line, right, we're used to, like this first one up here, if we were asked to graph this, right, it would be a number line. We would go to 2, and it's open circle, right, open circle, because it's not or equal to, it's just greater than. And greater than, we shade greater, larger numbers, right, shading towards larger numbers. So it would be shading to the right. All right, very similar with here for inequalities. We're shading basically just up or down, or still, yeah, left or right. We can stick with it. We'll keep it simple. Left or right. So, right, if it's a less than, we're shading to the left. If it's a greater than, we're shading to the right. We'll just keep it consistent. All right, and then we'll check. We'll see. So for equation 1, this is a less than. So for equation 1, we need to shade to the left. So this is our line here. So to the left of that is going to be down here. To the left, less than. Less than. And now for equation 2, this is going to overlap. We've got greater than or equal to, but again, that didn't bother us because they made the line solid. If it was a less than, it would be a dotted line, in case they ask you that. All right, greater than or equal to, greater than, we're shading to the right. So now we're going to find our line, equation 2, and we're going to shade to the right of equation 2. And now we can see where they overlap, right? Where it's both shaded regions intersect. So this is going to be our highlighted region, is down here in quadrant 4. This is where our solution would be. So if we chose any point in this region, so like 5, -5, 5, -5, bam, that is going to work for both of these. And we can check our work, right? We might as well while we're here. This is looking good, but just to show you guys how to check your answer if you're wanting to know, we'll go over it. So we've got our x. We're going to check 5, -5, so x comma y, and we'll plug it into both. So let's see, y, so -5 for equation 1, is that less than or equal to -1/2 of 5 plus 3? And we'll choose a calculator. We'll just keep it kind of quick. All right, so half of 5, so that's -2, so -2.5 plus 3, that's going to be positive 0.5. And is that greater than or equal to -5, right? It's a positive number, so yep, it definitely works for equation 1. Let's check with equation 2. So again, I'm just plugging in x and y. So -5 is greater than or equal to 2 times 5, x minus 2. So this is going to be 2 times, hold on, let me just double check here. Y is -5, greater than or equal to 2 times 5 minus 2, all right? So -5 is greater than or equal to 10 minus 2. -5 is greater than or equal to 8. Ooh, so that looks like it does not work. Let's just check. So we're seeing that it does not work, right? This is not true. The alligator is not eating the larger number. And this is actually really good that we're doing this in our video, that we've got a problem like this where we did get it wrong. So we can kind of learn, what do we do in that kind of situation? Because this might just happen to you too on your exam, where you work it out and you see, oh wait, that doesn't work. So now we need to pivot. Okay, so something that I was looking this over, something that I noticed too, I forgot to mention earlier, is we're used to graphing inequalities, and it's usually like with x, right? Looking at a number line, this is the same as like the x-axis going left to right. But when we're graphing an inequality, it's no longer, right, x equals, we're focusing on just the y. So I did kind of lead you guys a little bit astray with this. So it's okay, we're gonna update our notes. I didn't need to erase all that, but it's okay. So if we're looking at a less than, because we're dealing with y, the y-axis is going up and down, right? So positive goes up, negative goes down. So if our y is less than, right, if y is less than, we're going to need to shade down, right, because it's in the negative direction. Versus if our y is greater than, we're going to be shading up. So that's my bad. I forgot to mention that earlier. I was thinking while saying it, I was like, wait, this doesn't look right. But it's okay. It's good. We went through a sample of doesn't work, and we pivot. Okay, so that was important information. All right, so let's erase and let's go back, right? Anytime we do something wrong, we're going to take a deep breath. We're going to recenter ourselves, maybe kind of like zone out for a moment, look away, look back, fresh eyes. We're going to pivot. All right, so I need to update our arrows. So I'm going to reset. I guess I could have just erased, cleared everything, but it's okay. I'm already committed. Hang on. All right, that looks better. So we've got equation 1 and equation 2. Now we're going to follow along with this. Again, why is it that we're shading up and down and not left to right? It's because this is why I wrote it here, and then I forgot. I completely forgot to mention this. So I apologize. So it's usually y equals mx plus b, because on a normal number line, it's x equals, we're looking at the x-axis going left or right. But when we're graphing a linear inequality, right, a line on a coordinate plane, it's y equals, so we're focusing on the y-axis going up or down. All right, so for equation 1, this is a less than, because again, it looks like an L with really bad posture. So for less than, we're going to shade down. And for equation 2, we're shading greater than, we're going to shade above. And actually that doesn't change for equation 1. We shaded before, if you remember, to the left, and to the left or down. Notice that's the same direction. So we're still with equation 1, focusing on this area below the line. Below the line. All right, now for equation 2, because it is a greater than, see how this changes? Before I said, oh, like with x, we're shading to the over to the right, but it's y equals, so we have to shade up. And now, ooh, that changes the direction. So we're going to be shading up. We're shading up. And we'll plug that in, fill that in. Okay, so now let's check. We'll pick any point. We could even do the origin. That's easy. Let's see, 0, 0, if that works for both equations. So again, it should work. It should satisfy both equations. That's how we'll know we're good. All right, so let's plug this in. So for equation 1, I'll even color code equation 1. Instead of y, it's going to be 0 is less than or equal to negative 1/2 of 0 plus 3, right? That cancels. Is 0 less than or equal to positive 3? Yes, right? The alligator is eating the bigger number. Now let's check for equation 2. 0 is greater than or equal to 2 times 0 minus 2. Anything times 0 cancels. 0 is greater than or equal to negative 2. Yep, alligator is eating the bigger number. Yay, we did it. So that's how we can know this is the correct shading. So if there's any takeaway from this video, hopefully it's not like, wow, Mrs. A completely forgot what was going on over here. It's okay if that's your thought, but big takeaway is checking our work, right? This is highlighting the importance of checking our work. Mistakes happen in math and it's okay. We learn from them, right? For this example, we learned, okay, when we're, again, graphing a linear equation, it's y equals, so the shading is above or below. So greater than is above the line, less than is below, because it's y equals y, up or down. All right, so in this case, we would, you just click and it would automatically click on that region, and then you move on to the next question. All right, well, that concludes our video looking at inequalities. Again, if you guys have any questions at all, please let me know. Send me a message in Canvas inbox. But I hope this helps just give you a kind of refresher on inequalities as we get ready for your state testing. All right, that's it. Bye, guys.